This video presentation is from Chapter 14.6 from our textbook. This fifth video in the series for this section covers making a buffer of a specific pH and buffer capacity from a weak acid and a strong base. The question is, how would you prepare 1 liter of a pH 4 buffer with a total concentration of 1 molar using only formic acid and 2 molar sodium hydroxide? This is preparing the same buffer as we did in the previous problem. So again, the acid component of our buffer is formic acid with a pKa of 3.74. The base component of our buffer is the formate ion. We want our buffer to have a pH of 4. The total concentration or buffer capacity will be 1 molar. And we're going to make a total of 1 liter of buffer. But this time, instead of being given formic acid and sodium formate, we're only allowed to use formic acid and a solution of 2 molar sodium hydroxide. We already solved in the previous question that to make this buffer, the concentration of the formic acid will need to be 0.355 molar, and the concentration of the formate ion will need to be 0.645 molar. These are the concentrations that give a pH of 4 and a total buffer capacity of 1 molar. Notice that we have formic acid as one of our reagents, and we can use that to make this buffer. But we're not given any source of formate. How are we going to generate or create the formate ion? Let's look at what happens when we add sodium hydroxide to formic acid. Sodium hydroxide is a strong base that produces the hydroxide ion. Hydroxide ions will react with acids, like formic acid, in reactions that go to completion. In this case, the reaction of formic acid plus hydroxide will make the formate ion in water. So notice we can generate the formate ion using sodium hydroxide to convert some of the formic acid to the formate ion. Since this reaction will go to completion, we want to use a stoichiometry table rather than an ICE table, and we'll do the calculation in terms of moles rather than concentrations. So I've set up a stoichiometry table here for the reaction above. Remember, I stands for initial, S will be our stoichiometry step, and F will stand for final. Since we want to do things in moles, we first need to figure out how many moles of each of these species that we need. So we already know that we need 0.355 molar of the formic acid solution. This means we're going to need 0.355 moles of formic acid per liter, but we're going to be making 1 liter of buffer. So we need 0.355 moles of formic acid. How many moles of the formate will we need? Well, we want it to have a concentration of 0.645 molar. And again, we're making 1 liter of our buffer, so we need 0.645 moles of the formate ion. These, however, are not our initial values. They're the values that we want in our final buffer. So we're going to put these values in to the F row of our stoichiometry table. We don't know how much to start with, so I'm just going to go ahead and put in some variables, y and z for that. We're not starting with any formate, so we'll go ahead and put in a 0 for the initial amount of the formate ion. Remember, this is what we're going to be generating by this reaction. For the stoichiometry row, we can use our minus and plus x's like we always have. So we're going to lose x of the reactants, and we'll be gaining x for the product. Remember that the final row is always the initial plus the change. So that means for the formate ion, our final row should just be equal to x, or 0 plus x. We also know that we want to use up all of the hydroxide ion. This will be our limiting reactant. We don't want any of that left over, we just want to have the formate and the formic acid. So that means that Z minus X should be equal to 0. This will allow us to solve for Z. Z is going to be equal to X. That's going to tell us how much hydroxide we're going to need to add. The final row for the formic acid is Y minus X, which again should be equal to 3.55. I'm going to bring this up here so I have a little more room. So that we have Y. We already know our value of X is 0.645. And we want that to be equal to 0.355. So we can solve for Y. We add 0.645 to both sides, and we get that we want to start with actually 1 mole of formic acid. Going back to our hydroxide, we said that was going to be equal to X, which was 0.645. And that's how many moles of hydroxide that we want to add. All right, I'm going to move to a new screen to make some more space. Just remind us what we have. So far, we have figured out that we want to add 1 mole of formic acid, and 0.645 moles of hydroxide. Combining these two species will end up giving us 0.645 moles of formate And even though we're starting with 1 mole of formic acid, when we add the 0.645 moles of sodium hydroxide, we're going to only have left 0.355 moles of formic acid, because 0.645 moles of it were actually converted to the formate ion. Okay, so now we just need to figure out how many grams or milliliters of each thing that we're going to need to add. So we want to add 0.355 moles of formic acid. The formic acid had a molar mass of 46.03 grams per mole. And this was a pure liquid with a density of 1.220 grams of formic acid per milliliter. So we find that we're going to need 37.73 milliliters of the formic acid liquid. In terms of the sodium hydroxide, we want to add 0.645 moles of hydroxide. There's 1 mole of hydroxide per mole of sodium hydroxide. And we're getting our sodium hydroxide from an aqueous solution that had 2 moles of sodium hydroxide per liter. I'm going to go ahead and put in the conversion between liters and milliliters in here as well. And when we multiply this out, we find that we'll need 322.5 milliliters of the 2 molar sodium hydroxide. So our procedure to make this buffer, remember that we're making 1 liter of buffer. We're going to use a 1 liter volumetric flask. We'll use a conditioned pipette to add 37.73 milliliters of the formic acid liquid. We'll use a conditioned pipette to add 322.5 milliliters of the 2 molar sodium hydroxide. Both of those are going into the volumetric flask. We'll add DI water with swirling to mix. And we'll add DI water until the bottom of the meniscus reaches the calibration line. And then finally, we'll cap the volumetric flask and mix thoroughly. And that's how you can make 1 liter of a buffer with pH 4 from formic acid and sodium hydroxide. The next video in this series will walk through the calculations of how to determine how much 2 molar hydrochloric acid we would need to add to cause the pH of our buffer to decrease by 0.1 pH units.